post practice problems for chapter 12 and for what we've been doing out of chapter 15. I will do that. I'll post them on Blackboard. I mean, otherwise, in the meantime, going back over what we've been discussing is good. I mean, rereading your notes and reworking the stuff we've done in class is also a good thing to spend time on. I will also be posting your first project problems on Blackboard. Again, they'll be due a little time out from now, but sometime over the weekend they'll appear on Blackboard too. Tuesday, when I see you again, I will give you an actual paper copy, but I just was kind of, I don't know, I've been getting questions about the practice problems and the project problems, so I'm just kind of letting you guys know that I will be posting things on Blackboard, so.
And those are chapter 12 and 13, or just chapter 12?
The first project problem will be over the stuff we're doing now. So again, it's chapter 12, and then technically cylindrical and spherical are in chapter 15. Okay. There is no chapter 13 on it. The practice problems, it kind of depends on what role I get on. I'll probably only post chapter 12 and a little bit from chapter 15 right now, and as we get into chapter 15.
Awesome. Okay.
All right, the next section is chapter 12 material, and again, the theme is just thinking in 3D and doing various problem solving in 3D. So this problem says we have 3 points, and any 3 points in space can form a triangle. And actually, you also can form a plane. So any 3 points can also dictate a plane. If I turn this tilted like this, here's my 3 points, and there's a plane slicing through them. So any 3 points can form a triangle, but then also you only need 3 points to help you define the direction of a plane. So in this question, though, we're being asked to find the lengths of the sides, and then from that determine whether it's a right triangle, an equilateral triangle, an isosceles triangle. So you're going to have to dig back in your brain from geometry class. And we're going to work with rectangular coordinates. So to find the distance between 2 points, because that's how you're going to find the lengths of the triangle, you're going to find the distance between each of the pairs of points. You follow the formula that's on the top of our packet of notes. So distance is the difference between the x's so picking the first two, P and Q. Again, you guys, I appreciate individual minds, and so, do whatever is your natural instinct to be doing this correctly. I think that I grew up when people didn't get labeled ADHD and stuff like that, but I probably am somewhat in that spectrum. And if too much stuff is written down, it's like my eyes get too buggy. So, and I don't read things correctly. So for me, it is helpful to just look at the points and say, okay, one x is 3, the other x is 7, the difference between 3 and 7 is 4, and to just write the 4 down. Okay, if you want to write down the coordinates and subtract them, it's fine. It's just when I'm doing it, if I start to write too much down, that's when I tend to make more typos. Okay, so the y is -2, the other y is 0. The distance between -2 and 0 is 2. So then I'm going to have 2 squared. And then one z is -3, and the other z is 1. The distance between a -3 and a +1 is 4. And so the distance between P and Q so I'm finding the distance between P and R, that'll be a second side of the triangle. So one x is 3, the other x is 1, the distance between 3 and 1 is 2. And then -2 is one of the y's, +2 is the other y. The distance between a -2 and a +2 is 4. And then I still have a -3 to 1 like I did before, and that distance is 4. So we get what, 32, oh, you get the same thing, 'cause it's so it's an isosceles triangle. It might be an equilateral triangle. It's not, okay. All right, then we need R and Q is the last side that we need. And so R and Q, 7 to 1 is 6, so 6 squared. And then 0 to 2 is 2, so that's 2 squared. And then 1 to 1 is 0. And so I get 36 plus 4 is 40. Okay. So it is not equilateral. If it were a right triangle, then the two shorter sides squared would have to equal the other side squared, but that's not true, so it's not a right triangle. The hypotenuse is always the longest side for a right triangle, so 6 is the square root of 36, so it's smaller than 40. So out of those three sides, square root of 40 was the longer side, but 6 squared plus 6 squared does not equal the square root of 40 squared, so it's not a right triangle. It is isosceles because the definition of isosceles is that two sides are equal. And it's possible for it to not be any of those three. But this one did turn out to be isosceles. All right, number 10 is a very similar question. It just has different points. So why don't everybody on their own work on 10 if you haven't already.